Here in this video, we're going to explore even and odd functions. And there's two ways we can go about identifying a function to determine whether it's even or odd, or possibly neither. A function is even when the graph is symmetric with respect to the y-axis. So we talked about symmetry with the y-axis before, and your function is odd when the graph is symmetric with respect to the origin. So we could look at the graph and determine, is it symmetric with the y-axis or is it symmetric with the origin, and you would know whether the function is even or odd. So here we have the test for your even and odd functions. A function, if we have y equals f of x, if we have a function, is even when for each x in the domain of your function f of a negative x equals the original function. So what this says is we take and substitute in the place of the function x, if we plug in a negative x, if that equals the original function, then we would have an even function. Now, for an odd function, if we replace a negative x into the function and we get the exact opposite of the original function, it's an odd function, which also means it's symmetric with the origin. So let's look at the example here and see if we can go through these two different tests. If we have f of x equals 3x squared plus 7, we want to test to see, is this an even function? Well, the test for an even function says we're going to replace here, we want to substitute in negative x. So here we're going to have f of negative x. So that says go to the function. Everywhere there's an x, we're going to plug in a negative x. So we would have negative x squared plus 7. Now, if we simplify this, we have f of negative x. Well, if we square a negative x, well, we're squaring the x, so it's still x squared, but if we square the negative, a negative times a negative is positive, so that makes this x squared, a positive x squared, and we still have our plus 7. And if we compare this to the original, doesn't this equal the original function above? 3x squared plus 7, 3x squared plus 7. So therefore it's equal, so that means that our function is even. Now, how can we test to see if the function might possibly be an odd function? Well, then that means in the place of x, we're going to substitute again in negative x. Well, we know it's going to be even, so here, again, if we were to substitute f of negative x, well, we already know that that's going to be 3x squared plus 7. Now, what is the opposite of this function? Well, this part here that says we're looking at the opposite of f of x. Well, the negative or opposite of f of x means we're going to put a negative in front of the entire function, 3x squared plus 7. So we would end up with distributing the negative, we get a negative 3x squared minus 7. So this is the opposite of f of x. Well, clearly that does not equal to this over here. So these are not equal. Okay, so the f of negative x does not equal the opposite of f of x, so therefore it is not an odd function. So we have an even function. Now, of course, if we were to graph this function, and let's do that here. We have 3x squared plus 7. If we go and type in 3x squared plus 7, and we go to zoom standard, and we notice we have a parabola here, and I'm going to adjust this a little bit since we don't need the negative y-axis here. I'm going to make our y minimum 0 and look at the graph. And let's see, let's make that window, let's make the y minimum, let's go and make it a -3 even. Whoops, not -3. Let's make it a +3. So now if we look at the graph, it gives us a little bit better picture here of our parabola. And I'm going to actually make our x -5. Whoops. Let's make the x minimum a -5 and the x maximum +5. And that'll give us a pretty good representation of our parabola. So if I copy this over to our notes, then if we compare this, we see that because this is an even function, it is symmetric here with the y-axis. So in other words, if we fold right here on the y-axis, the left part and the right part would fall on top of each other. So that's another way we can determine that our function is even. All right, the next example here we have f of x equals 4x cubed minus 5x. So if we want to test to see if this function is even, we need to first find f of -x. And I'm going to take this and plug -x in for x, so we would have 4 times a -x cubed minus 5 times -x. And once we simplify this, we have a negative cubed. Well, a negative times a negative times a negative is still going to be negative, so that's a -4x cubed. And over here we have a -5 and a -x, so that's going to become a positive 5x. So we have a -4x cubed plus 5x. Well, does this equal the original function? Well, this is not equal, so therefore the function is not an even function. So that means we can now test to see if it is an odd function. Well, we already know that the f of -x, we've already calculated this, so we don't have to really do it again. We know that's a -4x cubed plus 5x. And what we need to look at is, what is the opposite of the original function? So we're going to put a negative in front of the entire original function, 4x cubed minus 5x. And there, if we distribute the negative, we get a -4x cubed plus 5x, because we're going to distribute the negative here. Now, does this equal, the question is this equal to f of -x? Does this equal the f of -x? Well, if we compare this to this up here, they are the same. So therefore, the function is odd. Now, remember, if it's an odd function, that also means it's going to be symmetric with respect to the origin. So if we look at the graph of this function here, we have 4x cubed minus 5x. So if I type in 4x cubed minus 5x, whoops, let's clear this out. So we have 4x cubed minus 5x, and I'll go to zoom standard. And to make this a little bit better, let's see if we make our window maybe -5 for the x minimum and 5 for the x max. And there we have a nice picture of our graph. So if we copy this, we can see that the graph is going to be symmetric with the origin. So therefore we have an odd function. And remember, symmetry with the origin basically says that if you have this point here, if you have x and y, then the point over here you're going to have -x and -y on the graph. So therefore we have an odd function. All right, one last example. F of x equals x cubed minus 2. We want to see if this function happens to be an even function, so we need to find f of negative x. So we would have a negative x cubed minus 2. And once again, if we have a negative raised to an odd power, that's going to remain negative. So we'd have minus x cubed minus 2. And does this equal the original function f of x? And the answer is no. This does not equal, so therefore the function is not even. And if we want to test for an odd function, once again, we already know that f of negative x is a negative x cubed minus 2. So we want to find the opposite of the original function. So we're going to negate x cubed minus 2. So by doing so, we get negative x cubed plus 2. And does that equal the original? I'm sorry, does this equal the f of negative x? And we'll notice that it's close, but down here we have a plus and we have a minus 2 here. So therefore the function is not an odd function. So in this case, your answer would simply be neither. So graphically, what that means is it is not symmetric with the y-axis, or it's neither symmetric with the origin. And if we were to look at the graph of this equation, x cubed minus 2, we could see from the graph here that it is not going to be symmetric with the y-axis or the origin, because if we were to look at the y-axis, clearly here's your y-axis. This graph is not going to fall on top of itself, and because this graph is not going here through the origin, this is not going to fall on top of it as we rotate around the origin. So here the function is neither even nor odd. So keep in mind, if you're looking for even and odd functions, an even function is going to be symmetric with the y-axis. Odd functions are going to be symmetric with respect to the origin. And if you're testing for an even function algebraically, if you plug a negative x into your function, it should equal the original function if it's even. If you plug a negative x into the function and that is equal to the negative or the exact opposite of the original function, you have an odd function.